I'm recording now. Um, we're just going to go over what we looked at in these pictures. One of the weirdest ones we looked at was that A and B and C are all the same color. Now, as you said, and I agree, A and C actually look like the same color, but B doesn't. The reason is because we look at the whole picture and we say this bit over here is in the shade. So if it's in the shade, but B is reflecting that much light, then B must be quite a bright color. And it's very difficult for us to discount that. But if we take a cut of the picture here and we put it next to A, it really is the same color. And it's weird also, as you do it, it almost looks like A is changing color. It looks like it's getting brighter as I put it into the shade. But I'm not, of course. This is not a magic trick. It's just that our eyes are used to that effect. When something is in the shade, we expect it to be a different color. We expect it to be brighter to reflect the same amount of light. So the same sort of thing is happening here. B and A are actually, in the left-hand picture, is actually the same color. So I rotate this here, you can actually see that A is the same color as B, and B is the same color as A. So this is a similar sort of illusion to the colored one on the right. If we go out further, we've got this illusion here, which is wasn't actually an illusion. If you zoom out for a moment, you'll see I'm pointing to the dress. This is the famous or the infamous white and gold or blue and brown, whatever color. I always see white and gold. Every time I look at this picture, I see white and gold. I've never seen another picture, but some people swear it's blue and brown. Is that what you said you see? Blue and brown? A lot of people say blue and brown or even blue and black. But I just see white and gold. So for me, when I look at this, this bit here and this bit here and the arms and they're all white. And this bit here is gold and that stripe is gold and this bit here is gold. So I'll try to see it. I mean, it's so difficult because we know that other people see it in this way. But the reason why me and you see it differently, and maybe why you and your parents may see it differently, is because neither of us know what the lighting was like at the time. If we go down to that picture of the Rubik's Cube, it's in the same way, this B and A, we can see what the lighting is like. And so they look different colors. That looks like an orange, that looks like a brown. But in the case up there, in the dress, we don't know what the lighting is like. It's unclear what the lighting is like. And so we use our imagination and we end up imagining different things. Different people see different things. So that wasn't intended to be it wasn't intended to be an illusion, but it ended up being an illusion. So this is all to do with color. Over here, we have a very interesting, this is a different kind of optical illusion. The picture of the woman. What this is now, these are the negatives, the negative of her picture. So at the back of our eyes, we get these nerves. In fact, let me get a picture of an eye for you for 1 second. So at the back of our eye, we have cones and rods, and they detect the light coming into our eyes. The cones are specific to color. And what happens is if you shine a load of light at your eyes, the cones and the rods, they start to get a little bit tired. And then when you look away, you see the opposite. So you may have noticed this. If you look at a light for a couple of seconds and look at a plain wall, you'll see a sort of shape of the light, but you'll see the opposite of the color. So if you're looking at, in fact, we can do this trick now. Actually, this is really cool. If you were to take, in fact, what I'm going to do, I'm going to take some squares here, okay, and then we'll do a little experiment. So you can do this in the video as well. You can replay it by pausing the video. But I'm just going to get some squares set up to be these colors here, okay. I'll just do that now. So I've made some green, red, and blue rectangles. The opposite color is the one on the other side of this. So that's the primary color. The opposite is this one here, which is a sort of cyan. So, and then the opposite of the blue is a yellow. The opposite of a red, sorry, I misnamed that. The opposite of a green is this one called a magenta. Over here it's called violet, but anyway. And then the opposite of the red is cyan. The opposite of a blue is a yellow. So I'll show you what I mean. I'll set those up now. Okay, so we've got these 6 colors. Now, what I'm saying is that the way that this illusion works here, when you stare at her eyes, in fact, if you're watching the video, you could do this yourself. So basically what you're going to do is you're going to stare at her nose, pause the video, stare at her nose for about 30 seconds, and then unpause the video and have a look at this white this dot over on the right-hand side. What you'll find is that you'll see the opposite of this. This is a negative of her face, and then you'll actually see the real version of her face. So we'll show you, and I'll demonstrate that in a more simple way down here. So now we're going to take an identical shape here, but this time we're going to make this one a white. Okay, and you can experiment with this one as well. So we'll zoom in. So we just want to get the rectangles reasonably big. Oh, that's about, okay, I'll just have to make the rectangles a bit bigger. And then zoom in. Okay. So what you want to do is you want to try to make sure you can see all of these rectangles. So you want to arrange you want to be able to see all 7 rectangles on your screen. You can follow me if you like. There you go. And if you were, for example, to look at the green rectangle for about 20 seconds and then look at the white rectangle, then you're going to see the opposite of green, which is magenta. You could, if you want, look at the red rectangle and then look at the white square, and the opposite of red would be cyan. Or you could do it the other way around. You could pick a yellow one and the opposite of yellow would be blue. It helps if you had a go at that on the video, that's why this worked here, you see. So we've got, those are all the color illusions. And then we've got over here, we've got just 3D illusions. When we are looking out of our eyes, we're actually just seeing we're seeing two-dimensional images. We know we live in a 3-dimensional world, but we're actually seeing 2-dimensional images. And this means you can trick people by drawing an object which looks like it would look if it was 3-dimensional. And if you look at that at a particular angle, you presume it's a 3-dimensional object, but in actual fact, it's just a picture. Someone's drawn this, as you can see with a pencil. So you have to trust me on that point. It's not actually a hole in the table. Someone's just drawn a picture. Over here, we have illusion. They could have done that optical illusion as well, couldn't they? They could have, in fact, made a hole in the table and then drawn around it to make it look like it was just a drawing. And actually, I think I've seen things like that drawn as well. Over here, we have these are all parallel lines, but they look like they're not because, again, we're making assumptions we see the way these are all arranged, and we assume from the way that we've seen other things that these lines must be not parallel. So you can see that they're parallel by simply seeing they're that far apart there. If you follow them all along to the right-hand side, they're still the same distance apart. The same with these two. The same distance apart. So it's very, very confusing, that one. This one here is quite interesting. If you look at it from a certain distance, it looks like you've got a blue ball, a green ball, a red ball, a blue ball, and so on. But if you zoom in, you always knew that the blue lines are going through it, but the ball itself was actually the same color as that one and that one and that one. They're all the balls are the same color. So this is just really to show us that the way that we see with our eyes is not actually that perfect